let's consider how we may implement a queue using our abstract class and also the STL list. STL list is the implementation of a doubly linked list, and it can contain whatever types of items and objects you'd like. In this specific implementation, you can see in the private data we have a list of integers that represent the elements in the queue. This class that we're writing has as a private data member this list of integers, and this is an example of composition. So you'll see that the implementations of all of the member functions of our queue class will basically be wrappers for calls to the STL list implementations underlying it. You'll notice that we're using public inheritance from the abstract base class. This is just to specify that we will be supporting all of the pure virtual public functions within implementation. So that is, this list in queue class will be providing all of the functions of the queue ADT. Okay, let's look more specifically now at the implementation. You can see the first function is front, and all we do for front is we can check if the queue is empty. The proper behavior would be to throw an exception or some other type of error handling. Instead, we just arbitrarily return the value -1, so it's assuming our list only contains non-negative integers. Otherwise, if the list has elements, we return the front element by calling the front function of the list class provided by the STL implementation. Next, to check if our list is empty, we just return the value of the Boolean returned by a call to the underlying list's empty function. Similarly, for size, we call the list STL's implementation of size on our private data member queue, and for pushback and pop front, it's very similar. So for pushback, we call the underlying queue's pushback function with the given value, and for pop front, if the list is not empty, which is our underlying queue is not empty, we just call its pop front function. As you can see, our list into queue class is a public inheritance of our abstract in queue class, which means that it is providing an implementation for all of the operations of the queue ADT, but it uses composition in order to have an STL list of integers, and all of the implementations are wrappers for calls to the STL list implementations underlying it. Now, let's consider an STL vector queue class. In this example, we will have our vector int queue class publicly inherit from our pure abstract base class int queue. This means that this class will implement all of the public pure virtual functions of the int queue class in order to be instantiated. In other words, it will implement all of the operations of the queue ADT in order to be instantiated. You'll notice that our private data member is an instance of an STL vector of integers called q. Recall that an STL vector is basically a dynamically sized array, so in this implementation we are keeping the elements of the queue in a dynamically sized array, and as we will see, the implementations for each function are basically just wrappers for calls to the underlying STL vector implementations. So once again, with front, we check if the vector is empty and return -1. The more appropriate implementation would probably be to throw an exception. Otherwise, we just return a call to the vector's front function. Similarly, for empty and size, we return calls to the underlying STL vectors empty and size implementation respectively. Now, for pushback, it's once again a call to the underlying STL vector's pushback function with the given value. And finally, for pop front, we check that our vector is not empty, and if it is not empty, we call the underlying vector's erase function and pass to it the beginning position, which is Q begin, is passing the iterator for the beginning of the vector. As we can see, just as with the STL list implementation, this is an example of composition where we have the STL vector class containing all the data, but then we also have inheritance from the abstract base class into Q in order to ensure that the QADT operations that are specified in that interface are implemented. In this segment of video,